Hello, I am Hiran PY from Mechanical Branch. My roll number is 17101101143. Today we are going to learn about matrix multiplication. Before starting with it, we should first know some of its properties. So, let A, B, and C be n into n matrices. I is the n into n identity matrix, and O is the n into n zero matrix. So the first law, commutative law. So what this law says it, A into B is not equal to B into A. The second law, associative law. This law states that A into B, result of A into B into C is equal to A into the result of the multiplication of B into C. Let's look into some of distributive properties. A into B plus C equal to AB plus AC. B plus C into A is equal to BA plus CA. The next law is one of very special laws, the multiplicative identity property. This property will be used for many sums in your future, so this one is very important. An identity matrix into another matrix, in our case it's A, is equal to A. And similarly, A into an identity matrix is also equal to A. Very similar to this property is the multiplicative zero property. So 0, I mean the O matrix is equal to 0, whereas A into the O matrix is also equal to 0. So these are some of the main laws. So you should remember these laws before starting a sum of matrix multiplication. For the first and foremost rule for matrix multiplication, to make it possible for the multiplication to be possible, is the column of the first matrix should match the row of the second matrix. So for example, let us take A A order of A matrix is a 2 by 2 matrix. Let us take matrix B of order 2 by 3. So A into B, so a 2 by 2 into a 2 by 3 matrix. So according to what I said earlier, the column of the first matrix should match the row of the second matrix, which in this case is matching. And the order of the order of the resulting A into B matrix would be of the order 2 by 3. So you can use this to check your answer after the matrix multiplication. So the column of the first matrix should be equal to the row of the second matrix, and the resulting matrix will be of the order the row of the first matrix into the column of the second matrix, just as demonstrated over here. So generally, we can write that a product of M into N matrix and N into K matrix is so this is the first and foremost rule. Like before doing a sum, we check this property, the whether this is the way this holds true or not. If it doesn't hold true for that question, then the sum is unsolvable. So now let's do some examples and get a clear understanding of how to proceed with the matrix multiplication. So this is our question. So the first and foremost work, as I told earlier, to check that whether the matrices are they possible to multiply. So according to the rule, this is a matrix of an order 4 by 2, while B is a matrix of an order 2 by 2. So the column of the A matrix is equal to the row of the B matrix. So it's possible. So let's proceed. Now we multiply the individual elements along the first row of matrix A with the corresponding elements down the first column of matrix B, and then add the results. Now this gives us the number we need to put in the first row, first column in the answer matrix. So basically this would give us following that, we multiply the elements along the first row of matrix A with the corresponding elements down the second column of matrix B, and then add the results. This gives us the answer we'll need to put in the first row, second column of the answer matrix. So here we go. -1 into 1 plus 4 into 0, which gives us -1. Now we use the same thing and we continue on along the rows and column as follows. So our answer matrix let us write the matrix again for convenience. So as I told earlier, and as we did over here, we're just going to do the same thing. We'll just take out this. So the answer matrix will be, as we said, according to this rule, the answer matrix would be of the order 4 into 2. So, as we did earlier, we multiply elements along the first row of matrix A with corresponding elements down the first column of matrix B, and then add the results, and this would give us what we need to put in the first row, first column position. So let us see what happens. Similarly, we do this same thing with the second row. So what we did is over here is multiplying the elements along the second row of matrix A with the corresponding elements down the first column of matrix B. And similarly, the multiplication of the elements of the first row of matrix A with the corresponding elements down the second column of matrix B, and for both add the results. Now along the third row of matrix A, the first column of matrix B. The second column of matrix B. And similarly for the fourth row as well. So our matrix will look like this after we multiply the elements along the row of matrix A with the corresponding elements down the column of matrix B, and then add the results. So the answer will be minus 11 minus 1 11 37 45 2 5 and 6. So this matrix is in order of 4 into 2. So this verifies the previous rule. Now let's take a look at another example. A equal to now our first rule. A is a matrix of order 2 by 2 and B is a matrix of order 2 by 2. So over here the multiplication is possible since the column of the row A is equal to the row of matrix B. So let's just follow the steps as we did in the first sum again. So A into B will be a 2 by 2 matrix. So simple as we did for the first sum. We multiply the individual elements along the first row of matrix A with the corresponding elements down the first column of matrix B and then multiply them. And similarly, we multiply elements along the first row of matrix A with corresponding elements down the second column of matrix B. I'm sorry, it's second column of matrix B. So repeat the same step, and main thing, we add these things. We add the results. Like for after multiplying the individual elements along the rows of matrix A with the corresponding elements of the column of matrix B, we add the results. So similarly, we do with the elements along the second row of matrix A. So here it is. So the final answer would be 31, 36, 33, and 38. So it's simple calculations, I mean simple multiplication and addition from this step. But to get into this step, we should check some properties as I told earlier. First and foremost property. So in generally, what is matrix multiplication? After seeing the whether the number of columns in row A is equal to the number of rows in matrix B, a general statement is we multiply the individual elements along the row of matrix A with the corresponding elements down the column of matrix B and then add the results. This would give us the number we need to put in the corresponding positions, like first row, first column. We add them and we get the number to be put in the first position. First row, second column, we multiply and then add them, and we then get number to put in the second position. Similarly, we get the number to put in the third and fourth position as well. So then for notation, I put as first position, second position, third position, and then fourth position. So it's as simple as that. Let's try another example. A is a matrix of an order 3 row by 2 columns, while B is a matrix of an order 3 by 2 as well. So the first rule, we check whether the column of first matrix, these two ain't similar. So multiplication of A and B is not possible. So therefore this sum is wrong. So in general, maybe I write general. The order column equal to the rows will be equal to that's all. So today we learned about matrix multiplication. These are the important laws to remember. The first property to be checked while starting with a sum, and as I said, some of the examples: multiply the elements along the row of matrix A with the corresponding elements along the column matrix B, and then add them. We did another example, the 2 by 2 matrix. This is a general statement for a 2 by 2 matrix. So practice as much as you can, because matrix multiplication is easy and it has many applications in near future. Like while doing engineering, you will require matrix multiplication, but in a complicated way. So better know the basics first. And it is fair enough than other chapters having a lot of formulas to learn and etc. So better practice, and if you have any doubt you can just check the video again. Keep working and do well. Thank you. This is Hiran PY signing off.